If this goes poorly, it may never see the light of day. If it goes well, it may become routine, because the last thing in the world I want is for you to not have access to things that could be useful when making access for such things is easy. So, fingers crossed. Let's learn something today, shall we?
Yes.
Yeah, why not? From the top, let's take a crack at it. Here's our agenda for today. We're going to wrap up the first half of the semester, continuous probability, module 5B. In fact, the problems that we're going to be working on today come from, good afternoon, come from the midterm prep module. So I'm really going to, in the first 7 or 8 minutes today, set the stage for what you can expect for the next 7 days, because your midterm is in 7 days. We're going to talk a bit about the midterm exam. And we're going to look at some example problems which wrap up everything that we've been working on for the first half of the semester. Those of you who were at homework help last night or had a chance to watch the video, this is taking raw scores through z-scores areas using the table in order to get a probability, proportion, percent, or percentile. That's what our focus is today. Is that right? On our schedule coming up, Monday you have a quiz. It's going to be quiz 2. If you're looking for practice quizzes for quiz 2, go to module 5B. They're at the bottom of module 5B. Bonus learning this afternoon after I leave here, because I don't want to go outside where it's sunny and nice. I'm going to go to my office and I'm going to go and do quiz 2, and I'm going to record it and I'm going to make that available to you. So while we may not have the time right now to go over quiz 2, or between now and Monday, at the very least, I can go over one of those quizzes from last semester so that you know what you'll be held responsible for on Monday. And so that will be posted this afternoon. So when you're doing your prep for that quiz for Monday, you can have access to that. And when it gets posted, I'll let you know. So that's going to be on Monday. Thursday of next week. Well, since we're done with the homework for the first half of the semester, we don't have homework to do on Thursday. But we do have a room. And we do have a time, and you do have a midterm exam the day after that. So if anyone is interested in having some sort of review session the night before your midterm with your professor, time that we already have booked, all you have to do is ask. Gerard, you want to do a midterm review session next Thursday? Cool, I can do that. Let's do that then. Guzman 250, 4:30 next week, same place we did homework. We'll talk about the midterm. You come in with questions, and we'll tackle it then. Sound good? Yeah, let the record show they're nodding yes. Breaking the fourth wall.
We game tomorrow.
Yeah, I know. So let's do this. We've got midterm prep stuff that I want to go over. So take a look at the midterm prep module if you want, but that's what we're looking at right here. I want to set the stage. I'm going to tell you what the rules are for your midterm exam so that they're not unfamiliar to you in a week. You will have 50 minutes to complete the midterm exam. After 50 minutes, I will start collecting them in the order I handed them out. That means the midterm exam doesn't necessarily start at 1:30. If we started right now, 1:34, I would give you until 2:24. You have 50 minutes. Don't cheat. We've been over that. Don't cheat. Bring your own calculator. $3 calculator is just fine. The things you need to do for this exam, add and subtract, multiply and divide. Maybe take a square root. We don't need a high-tech calculator. You can use a graphing calculator, a high-tech calculator if you want to. It's not required or necessary. You cannot use your computer as a calculator, and you cannot use your phone as a calculator, and you cannot use your neighbor's phone, computer, or calculator as your calculator. $3 will get you a cheap one at the bookstore. That's all you need. Tables for the exam will be provided. Same is true for the quiz. On the quiz, you will receive a table which looks like this, with a z distribution, and we'll take a look at this in a little bit, with a z distribution on one side and some binomial probability tables on the other. This is what you'll be provided for your quiz. It's the same thing you'll be provided for your exam. Tables are always provided. They're tools to help expedite the conceptual understanding of material. While tables are provided, formulas are not provided. But we've only really had 3 formulas. Thanks, Monica. We've only really had 3 formulas that we've used. The sum of x times p of x to calculate the mean of a probability distribution. The z-score formula, z equals x minus mu over sigma. And the one we looked at yesterday or Wednesday, mu equals n times pi for the expected value from a binomial probability distribution. Those are the only three formulas you're going to need to succeed on this midterm exam. So tables are provided, formulas are not provided. If you require assistance from OAS, let me know sooner rather than later so I can make sure that I get materials to them that they need in order to help us do what we need to do. Also in this midterm review, or preview, what do I call it? Midterm prep, I'm just calling it prep. In the midterm prep module, there are years' worth of old midterm exams. Going back as far as fall of 2014. I think I've been here longer than that. But if we looked at fall 2014 and look at the format of the exam, we see it starts with true false, then it goes to vocabulary, then there's a contingency table, just like you'll be asked to do for quiz 2. There's a binomial probability question, just like you'll be asked to do for quiz 2. There's continuous probability, just like you'll be asked to do for quiz 2. There's a histogram. It's not a histogram. It's a cumulative distribution. And a histogram. Now, you saw the histogram on the first quiz. That was years ago. The further back you go, the less it's going to look like the actual exam you're going to take. If we look at last semester's exam, we can see that, one, we do start with true-false. You could expect 10 true-false. Then it follows up with vocabulary. Now, vocabulary is not going to be exactly like this. I've tried, and if you look at the year's worth of old exams, you'll see that it does change from time to time. What I will not be doing is this, which is write the symbol for example, write the symbol for population mean, write the symbol for sample mean. Like, that's not how we're doing vocabulary. Though it will not be as complex as this, I still like what we were doing a couple of weeks ago where I give you a scenario and you're asked to identify some key pieces of information. So I'm crafting our exam to be more like we were practicing pulling out essential information from story problems. That way it's both application and identification at the same time. That can be your expectation for midterm, or for the vocabulary piece. But then again, a contingency table, which is just like those pivot tables we were making and generating probabilities. We've got a binomial probability experiment, like pulling balls out of the sack. Hey, here's another probability distribution, just like quiz 1. And here's continuous probability, where we will spend the balance of time today going over these particular problems. 40 questions, that's your midterm. So as per usual, about 7 or 8 minutes in, we've got the stuff. Questions, homework, quiz, test, course, personal, weather, I don't know. What do you got? Anything?
Could you go over again, like, if it says like percentile? Like,
yes, will absolutely be a big part of today, because we haven't defined percentile yet. And that was one of the things that was my soapbox from yesterday about I don't like questions that get asked about top 5 or bottom 5 or things like that. So I use percentile. So part of today is defining what we mean by percentile so that that can absolutely be used in these continuous probability questions. Percentile definitely covered on today.
So if we go through these and like get the answers to them, can we go over them next Thursday?
Absolutely.
Okay.
Yeah. So normally, like I've said, like I don't like to give answers, but I also don't feel like taking something down that's already on Sakai. The answers to the midterms from last semester are available too, so like you can find all of that stuff. Let's see, what is all that stuff? Yeah, there's more stuff on here too. Like, you know, this is all context. And do I expect you to do 3 years worth of old exams in preparation? No. I mean, if you've got a handle on it and you see these questions and you can do it, that's great. These are really just, if you've been doing what we've been doing all semester, then this is just another application of it. But what I do think these are particularly useful for is sit down. Can you do it in 50? Can you do it in 50 minutes? If you can do it in 50 minutes, that's great. If you can do it, but it takes you 2 hours, that's not so great because you don't have 2 hours to take it. So use it as an opportunity to see, am I efficient enough at solving these problems to get through? Because the other problem that always arises is that true false takes longer than people expect them to. It's at the beginning of the exam. I've tried to explain to people, save them for the ends, do the math first, and then spend as much time as you have left to answer true false. People want to do the true false first, always ends up at the beginning of the exam. So sometimes true false questions, especially under the pressure of the exam, can take a little bit longer. There's years worth of true false questions so that maybe you can see, oh, he usually asks a question about what the z-score of the mean is, or he asks about the mean of a binomial probability distribution. There'll probably be a question about that. Make sure you know what the z-score for the mean is. What's the z-score for the mean? When? Yeah. So only in normal distributions, right?
Always.
So only in normal distributions.
Oh, no, always.
No, always. That's correct. Yeah, always. Always. All right. Other questions before we start moving forward? So this is Form B from last semester's midterm. That's not it. This is it, yeah. This is Form B from last semester's midterm. And provided there's nothing else, yeah, that's what we want. And there's one of Rule's rules about fire safety. Everybody knows Dr. Steve Rule? Is that a thing that missed people? We know Rule's rules? All right, that's good. Still trying to keep in touch with what's hip with these kids now. So this is the last 5 questions on last semester's midterm. The problem as stated. The number of gas station visits a person makes per year is normally distributed, with a mean of 30 visits and a standard deviation of 5 visits. First thing I want to do is pull out the essential information. Start illustrating the problem because it can be easier to understand if you draw it. So we're going to take our time going through these 5 questions because these are basically the 5 questions that you can get asked with a problem like this. But please note that the lecture videos in 5B detail a lot of nuances in the way these questions can be asked. I'll describe some of those nuances as we go through these, but that's really the more complete source that you need in order to answer these questions. But if you can follow the 3 basic steps, or however many steps are needed, but it's no more than 3, then you should be able to accomplish anything you need in these types of questions, which is pretty useful because we will be following those same 3 steps from now until the end of the semester. This is what we've been building up to for the first half of the semester because it's the tool we used, the process we used to get to May, to get to the final exam. So buckle up. Or unbuckle because we're going to a gas station and presumably we're not in New Jersey or Oregon. We pump our own gas? We don't pump. I don't know. All right, so the number of gas station visits is normally distributed around a mean of 30 with a standard deviation of 5. There appear to be 3 pieces of essential information in this problem. Who can identify one for me? Yeah, Julian. Our distribution is normal. That's pretty useful. Bobby?
The mean is 30.
The mean is 30, Mohammed?
Population mean, I was going to say.
Yeah, because it doesn't say anything in there about sample, I'm going to go and say, by convention, this is population level stuff. Lord?
Standard deviation of 5.
Standard deviation is 5. Very good. So this is the essential information. Now, there are 5 questions which follow here, where we're going to be taking apart different raw scores, z-scores, and probabilities. The tools that we get from one to the next, I'll be outlining as we need them. But our first question says, what is the z-score associated with 24 visits per year? The first question is, what is the z-score associated with 24 visits per year? We start in this situation with a raw score, which is a number of visits. And we're going to convert that raw score, because the question asks, into a z-score. What tool do we have which will convert a raw score to a z-score? Right.
An equation.
Yeah, we have an equation. I tend to use an F word. I mean, I tend to. Do you know what F word I'm talking about?
I think so.
Logan, do you know? Is that the one you're thinking of?
Yeah.
Yeah, okay, good. That's the one we're talking about. Formula. Good. What's the formula to convert a raw score to a z-score? James, Jack. Got it right the second time, but I knew I got it wrong the first time.
X minus mu over standard deviation.
Sounds good. X minus mu over sigma. And because I'm trying so hard to keep these colors coordinated, I'm using the red color to stand for standard scores, the green color to indicate raw scores, such as X, and blue is given information. I mean, as best I can. That's also not what goes there. X minus mu over sigma. Brilliant. That's the first thing we're going to need to do in order to find what the z-score is associated with the raw score. So I'm going to start illustrating this problem. So I draw a horizontal line, but I want to be able to draw a shape that's associated with this particular problem. Because I did this wrong before. Lily, please.
Bell curve.
A bell curve, yeah. What permits me to draw a bell curve, Lily?
It's normally distributed,
How do you know?
because it says it.
Sounds good to me, because it says so. Very good. Let's see. I want to keep getting new voices for now. Anybody know what other information I can put on here? Julian, did you give me some today?
Yeah.
All right. James.
The mean z-score 0.
I don't have the mean on here yet. What's the mean?
0. The z-score.
Well, that's the z-score for the mean. So I can put the
Oh.
z-score for the mean on here.
The mean is 30 though.
And the mean is 30. All right. So the z-score for the mean is 0. Just in a normal distribution? Always. Raw score is in number of visits. And the mean is 30 visits. So right now, this is just the scenario. And in fact, a little bit later, I'm going to draw the picture again because this one's going to get messy. But this is the basic scenario that we're given. A normal distribution with a mean of 30. I don't have the standard deviation on here yet. You don't just drop the standard deviation on there yet. You end up using the standard deviation in the formula. Question 36 asks, what is the z-score associated with 24 visits per year? So I want to put 24 visits up here as a raw score. I got to put 24 up there to the left or the right of 30. James? Why?
It's less than 30.
Yeah. Yeah. Don't worry. It's going to make more sense, hopefully. Yeah, 24 is less than 30, so let's go ahead and put 24 on here. We're going to use the formula to calculate a z-score in just a moment. But before we start forging ahead with all of the other pieces that are going to end up over here, I want us to think back to when we were doing these problems with the empirical rule. Because the empirical rule says if you have a normal distribution, you can determine certain percentages. So if the mean is 30 and the standard deviation is 5, what proportion of visits, what proportion of what proportion of drivers make between 25 and 35 visits? Jake?
68%.
68%. And then if I go 25, subtract another, get to 20, add another. Now I'm 2 standard deviations below and 2 standard deviations above. Matt, 95% of people make between 20 and 40 visits. And then if I go from 15 to 45, Sarah?
Then 9.7.
99.7. But what we're doing when we start putting things on a picture like this and converting these raw scores to z-scores and eventually going to the table is doing the stuff we could do with the empirical rule, but with a bit more precision, a lot more precision actually. Whereas 25 is 1 standard deviation below the mean, 24 is just a little bit more than 25. It's not quite 20, but we use the formula to figure out exactly how many standard deviations below the mean it is. So I'll come here, and I want to just substitute the things into my formula. Z equals my raw score, 24, minus 30 is the mean, divided by 5 there. 24 minus 30, 6. So I get 6 over 5 for 1.2. So now I've got a z-score of 1.2. Whoa, hey, what's up, guys? You waving like you just don't care. Rachel, talk to me.
Well, it has to be negative.
What has to be negative? You're negative.
The z-score has to be negative because it's below the mean.
Now, James pointed this out, that 24 was less than 30. Z-scores have two properties. They have a distance. In this case, it is 1.2 units away. But Rachel, they're 1.2 units in the negative direction. Now, it's important because you use a formula, and when you solve a formula, you get a value. Like that's what solving, you use a formula, you solve it, you get a value. That's our value. It's negative 1.2. Now, conventionally, z-scores I'm going to write with 2 decimal places. Like if someone said they owed you $3.1, that's weird. I mean, it's almost as weird as saying that you owe someone $3.10 because who owes someone $3.10? You owe them $3. But you would say $3.10, 3.10. For z-scores, we follow the same 2-digit convention. Z-scores follow to 2 digits. So 1.20. Hey, the answer to number 36, negative 1.2. 1 down, 4 to go. The next question. What is the percentile associated with 24 visits per year? I'm about to define percentile. Percentile is not just a fancy way of saying percent. Percentile is a specific thing. And there's probably better definitions of percentile. But as far as I'm concerned, percentile means the proportion of observations that are below you. So if you're looking at 24, there is a certain number of drivers who make fewer than 24 visits, and that's the percentile. If there were some value over here, below which 99% of other drivers, let's say you drive an H3 or 4 or whatever we're up to now, and you have to stop for gas every single day, and you make 365 visits a year, 99th percentile. Because 99% of other drivers make fewer visits than you. If, on the other hand, you drive some sort of electric car or motorcycle even, like a Fisker or a Tesla, I don't know, Fiskers might have engines in them. If you don't stop at a gas station, you're in the 1st percentile because nobody makes fewer stops than you. Question. What's the percentile then associated with the mean? Brandon.
Is it the 50th percentile?
When?
Always.
Are you sure?
Yeah.
No. Though here it is. Though here you're right. Let me ask you another question. What percentile is associated with the median?
50.
The 50th percentile is the median. But in a normal distribution, Bobby, what do we know about the mean and the median?
Is that they're all the same because it's normally distributed?
In a normal distribution like we have here, the mean, the median, and the mode are all the same. So in a normal distribution, the mean is the 50th percentile. And that's always. But for any distributions, including those which are not normal, it's only the median, which is the 50th percentile. The median is always, the 50th percentile. In a normal distribution, so is the mean and so is the mode, but it's only in a normal distribution for that to be the case. Otherwise, the median is synonymous with the 50th percentile across the board. But this little section right here is going to tell us what the percentile is. In order to get there, I got to write out a couple more steps. I wanted to write P of X in orange, but I don't think the orange is writing real good, so I'll just underline it like that. P of X, which is proportion, probability, percents, or in this case, percentile, which is the percent or proportion of stuff less than a given value. There are probably more technical definitions of this, but it's the one that makes the most sense given our context. This is the 50th percentile. This is what we're looking for in this problem. The other two steps we need to answer this problem don't just involve a formula. We also have to use a table, and we're going to use our picture. The table is a z-table. These z-tables are available in the statistical tables module if you need them. But I think having hard copies is useful. So I'm going to hand these out. I think these are all got z-tables. Some of them have t-tables on the other side. Some of them have binomial probability distribution on the same side. Make sure you got one. If there's any extras, let me know. I lost count when I was talking to Connor, so help the brother out. These, by the way, are probably tables which I confiscated from quizzes, because after your quizzes, I don't let you walk with anything, because the last thing I want you to do is give answers to somebody else. So after I collect these, after you get done taking your quizzes or your tests, sometimes they have writing on them. If you want a cleaner one, let me know, because I got a bunch. And I'm going to put them in a box in the barn with the smallpox blanket, so it should all be good.
You're one of them.
Jack.
We'll take it over here. Jack will go.
He's not here.
We'll do that.
All right, cool. Nice. All right, we good? Cool. These are going to be useful. And again, we're going to be in Jeff's world of repetition, which just isn't because that's how my brain works. But there's repetition for certain points where I'm trying to overcome frequently occurring errors. Your table, your z-table, has two parts. It has an inside and it has an outside. On the inside of your table, there are a bunch of 4-digit numbers. Those 4-digit numbers represent areas. Just like area has 4 letters.
Oh, we have to keep this one?
Yeah, that's yours. Yeah, you can go all scribble jam on it if you want. Areas go in the middle. 4 digits, area. But not only is area in the middle of your table, area is in the middle of your picture. Your table has 2 parts, an inside and an outside. Your picture has 2 parts, an inside and an outside. On the inside of the table, you find areas. On the inside of the picture, you find areas. Your table has 2 parts, an inside and an outside. On the outside of your table, you find z-scores. On the outside of your picture, you find z-scores. Your table and your picture each have 2 parts, and those parts are the same. On the inside, you find the areas. On the outside, you find the z-scores. Your pictures and your tables have 2 parts. And depending on whether or not you're given a proportion, probability, percent, or percentile, or a raw score, you may be going from the inside out or the outside in. If I have a z-score and I need to get an area for my picture, I go from z to area. I go from outside in. If I have an area and I need to find its z-score, I start in the inside where the areas are, match my area, and then work that way to get the z-score, which is why the arrows are two directional, or the lines have arrows to two thirds of a triangle. Dr. Grant.
What's the top part of the thing for?
So our z-scores have, by convention, two spots. If you want to think about it like this, this part is the dollars and dimes. So 1.1, 2.3, $2.30. Across the top is your pennies. It could be no pennies. It could be 1 pennies. It could be 2, all the way to 9. So if I had a z-score of 1.19, I'd go down to 1.1, $1.10, 9 pennies. Go down to 2.3. If I only want 2.30, so you find the areas based on the intersection of what you have on the row headers and the column headers.
So for like 1.2 would just be 1.2 0.
That's correct. And the first column is the 0 column, because you look at the top and you see 0.00, I believe. 0.00. So that first column, did you find an area there? What do you got?
0.3849.
Bingo. So if you go to your table and drop down from 1.2, 0.2, and drop down from 0. So this is therefore 1.20. The next one over will be 1.21 and so on. For a z-score of 1.20, Brandon found, and hopefully you can all found, 0.3849 for an area. See 3849? Good on you. The last of the 3 steps is the picture step, which at some point may seem trivial, but is really what sets up the elementary arithmetic that we do to finish the problem. What I need is this piece, which is an orange. But I can't look that piece up directly from my table. You got answers? All right, not quite answers. 30 seconds. I can't look this directly up on my table because this particular Z table, and there are many different kinds, this one can only accommodate areas that look like this, that are one bound is at the mean and the other bound is some Z score, like we have here, from 0 to negative 1.2. We can't look this up directly, but we've got to do some elementary arithmetic. Jack.
So 50% is on the right, and then you have the area of 0.3849, so you add up 15.3849. 1 minus that, and you get the percentile area.
Most of that. I want to give you most of that. I think you may have taken the long way to get there, but you still got there. And I want to make sure, since we're introducing percentile as a technical term, that we know how to do that exactly right. So the percentile, remember, is everything that's left on the left side. If we had done it over here, this is not the percentile just because it's in the tail. That's not how it works. Percentile is the stuff to the left. It's everything less than whatever this value is, just so we're mindful of that. Now Sarah's going to clean this up a little bit, but you're right. So do you know what the answer is?
Yeah. 1.115.
Yeah. Sarah, how would you get there?
We just do 0.5 minus 0.3849 because you know that 50% is on the side.
So either of these ways. So what Jack was saying was, if we know that, and I was confused at first because you said we've got 50% on the right. I was like, why are you going on the right? Well, you don't care about the right. But if you add these two together and then subtract it from 1, you get that. Or as Sarah said, we've got this on one side. We get rid of this piece. And what we're left with is 0.1151. I would accept either the 11th or the 12th percentile. I believe it's probably the 11th because it can't be the 12th, but if you round 11.51 to 12%, I'm not going to bust your chops about that.
Oh, it says one to the nearest 12, so it's 12.
I would accept either one. I believe the right answer is 11th percentile, but I would accept either one because I'm not getting fancy about the fact that if you're not technically greater than 12%, you can't be the 12th percentile. If you round 11.5% to 12%, that makes sense too. Sorry.
I just have a question. Like when you're getting the area, you can just assume that it's going to be between the mean, right?
You can't just assume that, but because it's on our picture, we see that.
Oh, okay. So that's how you know. Okay.
Tell me more.
No, I don't know. I was a little confused with that, but.
Yeah, and we all are. We're learning something new. Your brains are going to buzz. Remember how your brains were buzzing last night? Those of you who were there? Yeah, we're still working on that. We're still growing new wrinkles in our brain. So try to talk it out a little more.
So like just because it's like the shaded part or like the area, it's going to be between them, like between the z-score and the mean.
Yeah, and the mean is the key part. Now, granted, if I look at this one and I look at my table, I don't see negative z-scores. Does yours have negative z-scores on there? Didn't we have a negative z-score here? Did we do something wrong? Should I put the Browns hat on? Julian.
I just had a question.
Hold on for the question for a second. Should I put the Browns hat on? Did I do something wrong because we have a negative z-score, but I didn't? Bobby?
No, because it's a normal distribution, so it's symmetrical, so the same, like, z-score would be the same on both sides, whether it's negative or positive.
So if I had a positive 1.2 for a z-score, I would get the same area as if I got the negative. Provided, as you're right, provided that we start here at the mean.
Okay.
Julian?
All right, so if this was a 1.2 instead of a negative 1.2, would the percentiles be 0.5 plus 0.3849, like?
Around 88th percentile?
Yeah.
Yep.
Yeah, all right.
Yep. So this value here, and I mean, without loss, we'll call it the 12th. We'll call it the 12th percentile. And to Julian's point, if we were over here at a z-score of positive 1.2 and had the same area over here, not gonna put that on here yet. Can you wait to the next problem? Okay, cool. We'll see exactly that. So in the next problem, we want to know what percent of people make between 24 and 36 visits per year. How far away from the mean in standard units? How far away from the mean is 24 in standard units? 6 raw units.
Standard units.
1.2, negative direction, but 6. So if 24 were, let's say, 6 units above, rather, if my raw score were 6 units above my mean, 30 plus 6 gets you 36. Remember, we just got done saying with the empirical rule, I could talk about somewhere between 24 or 25 and 35. 68% of stuff should be within 25 and 35. But now we've got a little more. Rather than 25 and 35, we've got 24, 36. What do you suppose the z-score associated with 36 is? New voices if we want them. Yeah, Ryan? 1.2. Sounds good to me. Hey, John, you know what area is associated with a z-score of 1.2?
0.3849.
Bingo. If we're on the left or the right side, The area, again, 0.3849. So, to Julian's point, 50% plus 38% gets us the 88th percentile. But to answer question 38, what percent of people make between 24 and 36 visits? We did start with raw scores of 24 and 36, which we converted using the formula to z-scores, negative 1.2 and positive 1.2. We took those z-scores to the table from the outside in, because z-scores are on the outside and we need the areas on the inside. We move from the outside in to get areas. Once the areas are on our picture, we can look at our picture and go, I know what simple mathematical operation needs to be done to find the total area. What simple mathematical operation is used to find the total area? Alex?
You add 3849 to 3849.
Yeah. If you want to get fancy,
Multiply it
what do you get?
what was it? 0.76. Or just under. Yeah.
0.7698. Question 38 says round to the nearest whole percent. Alex, round this to the nearest whole percent.
0.77.
77%. And that's the answer to 38.
Wouldn't it be 76, flat, because we're going off the 12th percentile? So it'd be 24.
I'm adding this area to this area.
Okay. I took both sides like of the test and subtracted it like 100 from that. Which would be
I don't want you to do it that way. I want you to look at the picture and add these areas together. 76 flat is wrong. It's low. It's low by a full percent. I wouldn't worry about trying to add or subtract percentiles. We have the picture so that we can add or subtract areas as we need to do it. Deep breath, wrinkles in our brain, 7 minutes, and then I cut you loose. You're doing good. Questions? Brandon?
Is this gonna be like the quiz?
Yep.
Maybe?
Yep. Numbers, I like to keep them simple. I just want to know if you can follow these steps. We got 2 more questions to do. So now we're going to work backwards from I give you a percentile, put that on the picture, use the table to give me a z-score. So I redraw our picture. And I put the mean on it, which is 30. And I put the z-score for the mean, which is always 0. And now I'm going to start with the 75th percentile. I start with this, because I'm given a percentile, or a proportion, a percent. And the question says, what is the appropriate z-score? So I have to take this proportion, put it on my picture, find an area in the table, go from the inside out to find the z-score. That's my goal, because the question says, what is the z-score? Start there, get to a z-score. I need to put the 75th percentile somewhere on my picture. It doesn't have to be to scale. It just has to be on the appropriate side. Which side of the mean does the 75th percentile go on? Anyone else want to jump in? Mikhail, yeah?
Right side.
Right side. So I'm going to put the 75th percentile here. Now I need to chop this picture up, find out what this area is. And again, this shape, this area, the whole reason I need this area is because my table accommodates an area with that shape. I'm trying to make this shape appear on here, centered at one side at the mean and the other at some z-score. Hopefully, using my picture, I can take that 75th percentile and convert it to an area. Thoughts, ideas? Leverage the central tendency, Muhammad.
You could subtract 50 from 75
Why 50?
because it's half.
What's half?
It's like,
You're good enough that I can get this together. All right.
it's like the median,
So this is the mean,
I
Mohammed.
mean, yeah, the mean, like if you go from both sides, it's 50.
But the mean is not the 50th percentile. You're here. Come on.
It's like 50, it's like 50 on one side and 50 on the other.
It is, but that's not always true for the mean.
Yeah.
It's always true for what measure of central tendency.
Median.
Right. But what do we know about the mean and the median in a normal distribution?
Very cool.
Very equal. Very good. So 50% on one side, 50% on the other. You say the 75th percentile, I subtract 50% from 75%, and what am I left with for the area?
25.
25. But areas, I go 4 digits. And that's our convention. Z-scores are 2 digits, like dollars and cents. Areas keep 4 digits. Just like the word area has 4 letters, keep your areas to 4 digits. And this goes back to Bobby's point of not just wanting to subtract the percentiles. I want to make sure we are as precise as we can be when we can. Our goal in this problem is to find out what's the Z-score associated. This is where we need to get to. We've put our 75th percentile on our picture. We've determined the area. Now we need to go to the table. And I look in the inside or the outside of my table. Where should I be trying to find 0.2500? Ryan? Inside, because areas live inside, right? And again, if you started and went to like 0.2 and then 5 across the top, that's doing it wrong. 2 ways you know that's wrong. 1, that would give you a 2-digit number, and what we're after is a 4-digit number. And 2, Z-scores outside, areas inside. But as I'm going through here, I see 0.2389, 0.2422, 0.2454, 0.2486, 0.2517. I don't see 0.2500. Do y'all see where I'm looking? I don't see 0.2500. My table is broken. I give up. Math is hard. What do I do? What do I do?
Wouldn't it not matter because the Z-score would be the same whether it was in between the 0.486 and 0.517?
Might not be exactly the same, but it would be close. So if I chose, and you are, if I chose 0.2486, I'm only 14 10,000ths. 14 divided by 10,000. 14 10,000ths away from my target. If, on the other hand, you choose 0.2517, you are 17 10,000ths, a difference of 3 10,000ths. It's nothing. I don't really care which one you choose. 75th percentile, I would probably go above, but this is a more detail than we need to get in right now. But if you choose one of those, Julian?
No, I was just gonna say, like, so, like, a situation like that, you don't have to go, like, say, 675.
Nope.
No, okay.
There's one circumstance where we will because it's an important convention, and that's 1.645 for the 95th percentile. But that's the only one where we worry about 3 decimals for a Z. So if you chose 0.2486, your Z-score should be 0.67. If you chose 0.2517, your Z-score should be 0.68. I will accept either of those just the same way I would accept either 11th or 12th percentile. So that's the Z-score. There's one last bit with the last remaining moments we have, and that's to use the formula in question 40 to take the 75th percentile and turn it into a raw score. And that's just finding this value. And you go from Z-scores to raw scores using the formula, which is rounded to the nearest whole is 33. X minus mu over sigma. My Z is, let's say, 0.67 equals X, which I need to solve for, minus 30 over 5. 5 times that is 3.35 equals X minus 30. Add 30 to both sides. 33 and this should be a raw number, green. 33.35 equals X, rounded to the nearest whole. 33 visits is the 75th percentile. This is what we've been building towards. Stick around if you got questions. I'm also, like I said, I'm gonna make that quiz video for you. Otherwise, it's not that sunny outside. Rounded to the nearest whole visit is what Floyd says.
It's
true. Well, wasn't it 2 years ago? Was it last year? Yeah. So much, 5, 10,000. I think that would be. Yeah. In a way, they tell
You
us.
said that once before when I like.
I don't have to do it though.
I know, we're getting there. That's the next step. As soon as, so like in the stages of learning, like you don't understand it, and you understand it when somebody else does it, and then you can do it yourself. And the next step is, can you explain it? And I know you can do it.
Play the clock is hard.
Right. But if you can do it and you can explain it, then you become that much more of a master over it. I'm really happy with that. So you keep doing you. Yeah, and you can do this.
Yeah,
You can do
hopefully
this.
one day I'm gonna help them in the future. When they take statistics and I'm over.
Cool. All right, gentlemen.
Thank you.
Have a good weekend. Yeah, take care. Who wants what? Hey, Shake. Me too.
I just want to know like what I missed here, how I can. I don't know.
Yeah.
What would be a
Thanks,
good idea to get back on track and stuff.
Yeah. Let's take a minute.
Yeah.
Yeah. It's gonna take more than a minute to explain that right now. I
Yeah,
gotta
no,
clean
I
up the wipe
know.
down
I didn't
stuff.
mean right now.
No. Well, you got a midterm in a week. So let's. Do you have like 5 minutes right now?
Right now.
Let me clean up the room and then Joe, you sent me an email. Yeah, you know, Jill at home was working and she emailed me.
Really?
Yeah,
Okay.
that's all right. You got it. No, you got it too. Hey, good work yesterday too. You did great. I'm for a moment I was concerned. I was like, I thought that like I left. I was like, his name is not Joe, and he was just agreeing with it. Like he's totally Joe, but I literally got the 2 words.
Asked me for the 50% thing.
Yeah, drawbacks.
Yeah, sorry about that.
No worries. Hey, no, don't apologize. You do that every day. Crush it, Joe. What's up, Joe? All right, cool. Thank you as always. Yeah, all right. So let me shut it down and clean it up.